All right. Hi, everyone. This is Eric Archer from TI, and I'm with Fred Foch. And tonight we're going to show you how to do the digital mood project with Python. Fred, you want to go ahead and start us off?
Yeah. Hi, Eric. Good evening, everybody. Fred Foch here. I'm with TI as well. And I want to show you the digital mood ring. So let me switch over to my screen here. Eric, you can see my calculator okay, is that right?
I sure can, yes.
Great, thanks. Well, if you remember that groovy piece of jewelry called the mood ring, you might recall that it was a ring that you slip on your finger that changes colors with the temperature of your finger. And that somehow mystically informed you of what mood you're in. Of course, we know that's just mysticism, but it's kind of a fun little piece of jewelry to kind of think about as a coding project. And so at TI, we've made a coding project around the mood ring, and it uses some of these things that I have here in front of me to do some physical computing. And so I'm going to use this temperature sensor. This is essentially how the ring knows the temperature of my finger. I'm going to use this cable here to connect the TI-Innovator Hub to a TI-Nspire CX II calculator. And the TI-Innovator is something called a microcontroller. And it is a controller that's based on some TI technology that professional engineers use. And it has input ports, and it has output ports, and it has a speaker on it, and there's a little color LED right here on the surface of the board in here that we're going to use tonight. That little color LED is like the well, it's not a gemstone, but it's like the stone that is in the mood ring. And so turn this off, I've got technical problems here. And so the mood ring then is going to be created by using the temperature sensor and the color LED that's inside of the hub. So let's get started. I'm going to turn on my calculator, and on my calculator I have a pre-authored Python program that is going to do something called feedback and control, where the temperature of the sensor comes into the hub, it gets sent over to the calculator, the Python program makes a decision based upon that temperature value, and then decides what color the LED should be switched on in the calculator. And in this way, we're going to kind of model a mood ring. Now, there's a lot more to the project that we'll talk about as we go, but I kind of want to show it to you working first. So to get started, I'm going to take my temperature sensor, and since this sensor gives a signal off, it's going to be an input to the hub. So I'll go ahead and plug that in here. And then I need to plug the hub into the calculator, and that happens using this data port right here. There's a USB mini data port. And I'm going to take this calculator cable, this comes with the calculator, and I'm going to plug it into that data port. And then I'm going to take the other end, and I'm going to plug it into the USB port of the TI-Nspire CX II calculator right up here. And so when I do that, you'll see that a little green light comes on that says I'm ready to go. And then there's a program here, and I'm going to go ahead and run this program. Let me kind of turn the screen brightness up a little bit. Maybe you can see a little better. We're going to go through this in a little more detail later, but right now I'll just kind of run it. So there's a quick little key combination I can use to run this program. And let's see, I must have hit something that made an error.
It's always when you're trying to demonstrate something.
Yeah. Well, I must have hit a key when I was fumbling with it.
Right.
So, all right, here we go. So now, if you kind of look at this up close a little bit, you can see that it tells me what the temperature is. It says the temperature is 20.5 degrees. And you can see that there's a blue color right here. And then it also gives me a mood. It says that I'm hopeful. And so if I take this and let's imagine that I had a piece of fuzzy wire to wire this onto my finger like this, I could then measure the temperature of my finger, and you can see it just switched to cheerful. And the color of the LED right here changes. Oh, it just went to magenta right there, and it says I'm funny. I don't know that everybody agrees with that, but I'll take that right now. And so here is some ice. Here's some ice, and I'm going to go ahead and cool this off a little bit. I'll just kind of shove it in there, and we can see it kind of go down through. Its temperature is dropping, and you can see the colors are changing. There's the mood hopeful. There it is energetic, and as it cools, right there, and there it is happy, and so it's all looking good. So that's kind of the way the mood ring works. So what we've found is that students are very interested in coding projects that make something happen, and in this case, lights are coming on, and they can interact with it in a physical way, and it gives meaning to the coding that they may be doing in a class as an introductory coding project. So this is the mood ring, and let's dig into how this actually works. I'm going to switch back. Yes, go ahead, Eric.
Oh, sorry. Yeah. You hooked up the Innovator Hub to the calculator. You've got the one cable, which it looks like it's yellow, white, and red, and maybe black. That's the cable that goes from the Innovator Hub to that little temperature sensor.
Yes, this is the sensor right here. This little chip on here is actually the chip that does the temperature sensing. So this is kind of cool because kids really have an opportunity to be hands-on with technology. It's not a black box that's all sealed up. That chip is the sensor.
I love that. And then you're using what programming language is this?
So this is Python, Python programming language, which as you know, Eric, Python's becoming very popular in the world as a professional language, and it's also becoming very popular in the schools. It's a great first language. It's very readable and understandable. And we've just recently brought this to the TI calculator. And I think we've got a dandy editor for Python, and I hope that it's something that we can look at as I dig into this a little bit, and maybe you can ask some more questions about the editor when we do that. But yeah, Python's great stuff.
Yeah, I love it. It's great. Yeah, I would definitely love to see how you code this thing and how you get the light to work and the temperature sensor. So I'm going to hush up and watch you work.
All right. Well, let's dig in then. So what's really cool about this platform is that this is what a student would work with. And so, and again, let me remind you that you're seeing the final project, and we've got to rewind a couple of class periods to get to this point right here. But this is what the student would work with. And so a student doesn't need to be sitting down at a laptop in a lab or, have a laptop on their desk. They have this small little system right on their desk, and it's very portable and handy. It's easy for them to take it home as well. And, this is a calculator they may even have, for their math or science class as well, Eric. Here they can kind of just take it in and into another class where they're starting to do some introductory programming and do a little project like that. So, so let's take a look at this other piece of software. So again, this is what the student is working with. And what the teacher can work with is this. So this is a desktop piece of software. And, Eric, once upon a time, I was a teacher. And I used to have a kind of a projector board, kind of a touch smart board, and I would run this software on that board, and it was just great to use because you know, I could be in front of the class and show the kids how to use the calculator and demonstrate things. And so this software enables that type of thing. So this is the way that maybe a teacher might interact with the calculator and maybe demonstrate to the students how to get started with this project. But the way this project works is that you go to the TI STEM projects webpage, which Eric will tell us more about later. And on that webpage, you'll find a number of resources to help you get started. There are two that are particularly important. One is the file that we're looking at. There's two versions of this file. One is a version that goes out to students where the code is not entered into the editor. It's a blank page because we want them to code it. And then the other version, the teacher version, is one that has the code completed. So the teacher can, you know, give it a try and, you know, figure it all out before they work with their students. And that's a big part of what's available, but there are also companion videos now. And the entire project can be done by watching the videos and working side by side with the calculator. And I might add that in the videos, there's a lot more than just coding in there. There's a lot of science as well. And so the Mood Ring project is not just a coding project, but it's also a science project. And, you know, teachers can mix it up as they see fit. There's a lot of options of how to do this. But the way this project is set up is there are challenges. And so a student is faced with a very, you know, straightforward challenge. And in this case, they're asked to manipulate this LED that is on the hub. Remember this LED over here? It's blue right now. Well, there's a piece of code that's controlling that LED to make it blue. And since it's an RGB, that means red, green, blue, those three primary colors can mix together to make essentially any color that we can perceive. And so that's kind of cool. There's a lot of neat science theory behind color mixing and that sort of thing. But let's learn how to control this right now. This activity in and of itself is a fun little activity that students enjoy that is a great way just to get kind of, you know, whet their appetite of getting started with coding. And so to do this, I'm going to use the calculator pad over here on the left. And this of course, is just a zoomed in view of this screen right here. And so the keypad that you see is this virtual keypad. And so it's the same experience that the students will have. Now, I can move from page to page in this document. It's kind of like a PowerPoint. There's a lot of different pages by using this touchpad over here on the left. And so I'm going to advance to the next page. And here we see kind of our first challenge, which is to set the color LED to red. And so I'm going to do that now. And to do this, I'm going to kind of, since we're going to be kind of working at two things at once, Eric, I'm going to kind of try to manage my screen here so we can see both the view of this and my calculator and my video. So let me get this straight up for us here. And there we go. Let me set this right here. And we'll kind of get this straight to where we can see all this. And what I'm going to do is I'm going to disconnect from the handheld, and I'm just going to connect with my computer. And so this cable right here goes to my computer.
So now you're
and I'm
hooking
going
up
to control
to,
this with it.
oh, gotcha. You're hooking your Innovator Hub up straight to your computer that's running the TI-Nspire software, and you'll control
That's
the
right.
hub now with the software. I gotcha.
So that's kind of cool that you can kind of do it both ways here. And so get my screen kind of here where you can see it all. So you can see my hub and my screen okay here. Is that right,
Yes.
Eric?
Yeah, I can
Great.
see it. Yeah, it looks good.
Good. All right. Well, let's do this. Let's try to do this challenge. It says try to make the LED over here red. So to do that, I'm going to interact with the Python editor. Now, notice that there's an import statement here. Those of you that are familiar with Python know that Python is an extensible language that's extended by these things called modules. And so there are a few modules that are available on the TI CX II Inspire calculator. And one of them is the Hub module. And this, again, allows for communication between the calculator and the Hub. And so I've imported that because I don't want to burden students with that first thing in their program. So what I'm going to do is I'm just going to try to issue a command, and I'm going to find that command under the menu. And so a lot of times I'll hear people say, so when you program Python on the calculator, do you have to type all the commands in down here at the bottom? Because that'd be kind of tough, particularly with fat fingers like mine. I can't quite get it on those little bitty keys. And the answer to that is no, that's really not the way you do it. The way that you do it is actually using this menu button right here. So I'm going to press that menu button, and here I see a number of choices. And so I'm going to choose number 8, which is the TI Hub. And there's that import statement. I've already done that in this particular case in the editor. But the Hub has built-in devices. If I go down to the built-in devices, you can see that there are a number of them that are, hold on just a sec here, sorry. There's the color LED, which is right up here that I talked about. There's also another little red LED. There's a brightness sensor right here, so you can actually, detect the intensity of light falling on it. So that's kind of a little input that's built in. You don't have to add a sensor. And then there's also a speaker here on the flip side. It's kind of hard to see, but you can kind of see the grill there, and it says sound. So there's a little speaker. So you can make sound and music and that sort of thing with this. So, but what we're interested in is this color output. So I'm going to choose number 1. And then this is Python programming, and it's following kind of an object-oriented model, which is an important concept in computer science. And I think that the TI Python editor does a real good job of easing students into that idea of object-oriented programming. And so here I'm going to choose number 1. And it creates this color object, and there's a method of the color object, and the color object is the object that controls the hardware on here, this RGB LED. And there's a method in there that's called RGB. And so one of the things I want to draw your attention to is that there are 3 arguments for the RGB method. And those 3 arguments are the red, green, and blue values. And now, one of the things that I think I was talking when I first issued this, but something called a tooltip popped up that said that the acceptable range for this parameter is 0 to 255. And so there's kind of this built-in help that happens as the students interact with this. And so I want the challenge, you recall, is to make it red. And so I'm going to use 255, that familiar 8-bit number. And to make it red, I want it to be just full R, no G. So I'm going to press the tab key. Over here, there's a tab key. And notice that, and there's that tooltip, 0 to 255. Notice that the tab key is red. It lingers red so that students know the key that I just pressed. And so now I'm going to press 0. And then I'm going to press tab again. Look for that tooltip when I press tab. There it is, 0 to 255. And I'm going to press 0 again. Hey, that's my first Python program right there. And
cool.
I'm going to do some physical computing here. I'm going to run this. So I'm going to go to menu, and I'm going to go to number 2, and I'm going to do number 1. But before I leave this, notice parenthetically it says that there's a kind of a quick key combination that will do the same command, and that's Control R. This is just like the key commands that are on your computer. Some of them are defined a little differently on the calculator, but it works the same way. And I'm going to use that in the future. But for right now, I'm just going to press run. And notice that what happens, two things happened here. It turned red. That's the most notable. So, and that's good. So we got that one right, Eric. We got that first challenge. And so you notice that what's happened here is we've gone from an editor to a Python, what's called shell. Some people call it a console. And those of you that are familiar with Python programming, you'll see that familiar triple chevron, which is the REPL prompt. And so the REPL prompt in TI Python works the way you would expect with Python on the desktop. But so, let's go back. Go ahead.
Oh, sorry, real quick. So you made mention of something that's apparently common in the language of Python. It's not specific to a TI calculator. So it sounds like what you're saying is that when TI implemented Python on our devices and software, we try to maintain, the language as it was written, as it's available to everywhere, everybody in the world. We try to take what Python was and stick it on the calculator as Python, not something that TI has done that's different. So in other words, if you're familiar with Python, you'll be familiar with how to code on our calculators with a few benefits of menus. Instead of having to type the letters, those little letters in the bottom of the keyboard, we have menus instead. And then we have these prompts that kind of clue new programmers on what to put into that line of code. And that's unique, right? Mm-hmm. That's not necessarily out there in the Python world. It's something that we added. Yeah,
that menu-driven nature, I think so. Yeah, it's pretty cool. And it also makes the language more discoverable. You'll have students that will just, they're like, hey, I wonder, gee whiz, there's a command I've never tried before, and let's just paste it in and see what it does. And of course, we all know that play is a great way to learn. And so it facilitates that discovery for play as well.
Well, I think
that's pretty cool.
That's a great point. So what you're saying is if somebody were to use or to learn Python outside of the TI world, they would have to have some kind of guide to tell them what was possible. They wouldn't know otherwise. Whereas on the TI side, when you open up those menus, you can kind of see different things that you can do that are available. Mm-hmm. And a student or a teacher could try those things to see, hey, what does this do? What does that do? And I know TI is a guide for this kind of stuff too, but visibly seeing what's available is kind of neat.
Yeah, it is. And I think particularly with the hub, a lot of the commands are visible through the menu. And so, you'll get a kid, pretty quickly picking up they'll stumble onto the speaker and they'll start playing songs. And next thing you know it, you've got some kid in the back playing the long jam of In-A-Gadda-Da-Vida. And so, it's pretty great when kids get motivated to explore like that, I think. I love that.
Yeah, that's a very groovy song too.
Yeah, it is. All in the theme of the mood ring.
That's it.
Okay, so one of the things that I wanted to show you is that the editor still lives here, and we can simply go back using the control and the touchpad to the left. And here's my program. And it says, let's try to make the color dim. And so here is a great place for kids to explore a little. And they can just see what's the effect of changing the parameter by really a power of 10 here. 1/10 the value, 255 to about 25. And so let's look at this red LED. And we may not get the full effect here because of the lighting in my room, but we'll see what happens here. I'm going to run this using that Control R, and notice that now it's dimmer. And so the way that a LED is controlled is with software like this over here. And really the LEDs that are in a TV screen really kind of work the same way. And an entire TV screen can be painted to make a picture using these LEDs. And so the software is kind of the same way. So it's kind of cool. So let's continue on and see what other types of challenges we have in this. But before we do, let me kind of show you that there's also some interactive things in here that help you to explore the science of this. Here's kind of a little interactive simulation where you can grab a red square and drag it over the blue, and holy smokes, red and blue mixed together to make this new color called magenta, a secondary color. Similarly, green and blue mixed together to make cyan. And if you mix red and green, you get yellow. And if you mix all three, you get white. And so here's kind of a way for students to simply explore and play with the phenomenon. And then they get the opportunity to try to code that. There's even some little questions in here that if you want, you can assign this to the students. Otherwise, you can just keep moving on. These activities are designed to do what you as the teacher have time for, what you think aligns with your learning objectives for the students. And so you don't have to follow them verbatim. On the website, we give you some alternate paths. You can take to stay in the mood of the 60s here. You can do the long play album, or you can do the 45. If you've just got time for that one-hit wonder, just play the 45. Just do a little 2-hour session. But if you want the immersive experience, you can do the whole thing. So what I want to do here is to kind of extend what we just did and try to make some of these secondary colors that we saw back here when I mixed these. And so here the students have an opportunity to kind of make an intuitive leap that if I made white by mixing red, blue, and green together, how would I do that in software? You have any guesses there, Eric? How would you make white light?
Well, I remember that line of code you did before. You had the prompt showed red, green, and blue, and then it prompted the person coding it 0 to 255. So I would assume if you want all of those lights to turn on at the same time, you've got to put a number other than 0 into each of those slots.
Okay. Okay, let's see what happens. Let's try putting 255 in each of those. Do you want to try to put in 255 to each of them, or just a couple of them? What do you think? This is your life.
Okay. A lot of pressure here.
It is.
Yeah, let's do 255 on all of them and see what happens.
Yeah, okay. There we go. Let's see what happens. So this is a great opportunity to have a little hypothesis testing for the students. And, it's kind of interesting how quickly kids pick up on this. And, hey, Eric, I told you that I was a teacher. And I deliberately used to make mistakes to teach the students the ways of my error. And so you saw that I just got a Python error. And that error was because notice that the import statement is commented out. And so here we're kind of easing the students into thinking about imports. And so I'll delete that. Now this will activate that. And now we'll try running again. And let's see, from import TI Hub, import. Let's just go back and get, I think that whole thing.
Do it from your menu?
Go back and, yep.
Okay.
And that way I'll be sure to get it right. I forgot what I deleted off some of that asterisk stuff. Mm-hmm. So now we'll go ahead and run this again. And yay, there it is. Oh, wow. And sure enough, there's the three mixing together. Now remember those three colors are red, green, and blue together. And so anyway, so that's kind of cool. That's kind of fun. There's a lot to do with the color sensor. But what I would like to try to do, or with the color LED, what I'd like to do with you now is to kind of jump and take a look at the temperature sensor. Let's get that temperature sensor working. Because remember when I showed you that demonstration at the beginning, we had a couple of things going on. We had the temperature sensor reading in temperature, and that was coming into the Python program. There was a decision being made in the Python program, and based on the temperature that was coming in the Python program, a certain color would be turned on. And so I just kind of arbitrarily picked colors according to certain temperatures. I said something like from 18 to 20 degrees, let that be red, and let the mood message be energetic. And so this is an opportunity for your students to be creative. In the actual activity, there are suggestions for mood messages that are appropriate, and there are also suggestions for colors that they can make. However, this is an opportunity for students to allow their inner child to sing the praises of their knowledge, and so they can do what they want here, and so that's kind of cool. So let's do this. Let's go to the next mood ring, part 2, and in part 2, this is where we kind of start to get into the temperature sensor. And so the content is kind of broken up. It's chunked in a logical way that allows it to be digested in your classroom as you, the teacher, see fit. You can do the long play album, or you can do the 45 single, depending upon how much time you have. And so I'm kind of doing this real quick in just about 30 minutes. So we're really kind of blazing through here, but that's all right. Let me kind of show you what we have in here. Here are it's aligned with some learning objectives. Here's some of the mood messages that you can have the students do. Oh, I need to go to let's go to the one that has the actual, I'm going to go to this page sorter view where I can get a grand view of the entire structure here. And I'm going to jump to, here's some of the mood messages. So these are some of the suggested mood messages, and students can put those in and display them. There's an activity, there's one of the challenges that the students actually learn how to use the print statement to print this to the display. So that's one of the things they learn. And then after that, here you can see, here's kind of that print statement. And Eric, earlier you said that all of the Python statements that are in normal Python are in the TI Python. That's absolutely true. However, I also said that Python is an extensible language, and it's extended by the modules that TI has published and built in. So for example, TI Hub is a TI module that extends Python. And so inside of those modules, since the Hub doesn't usually run on the Python programs on most laptop computers, here you'll find commands that you won't find in normal Python. Same way with our rover. Our rover is a great little device where you can use Python to drive the rover on a course that helps the students to learn about geometry and that sort of thing. But inside of the modules here, you'll see that here's a couple of different modules that are TI modules that are not part of standard Python, but they work like normal Python. So here's some image handling stuff. This is great for image processing. Here's kind of some vector and pixel graphics. TI system allows you to save data and interact with other applications inside of the Nspire environment, like the data and statistics or the graphing packages and that sort of thing. And so you can make a very rich lesson between using the calculator's mathematics functionality and the Python programming capability. So there's a lot of stuff going on here. And in this case, I've used one of these commands that is a TI command. And so here I'm going to run this, and you can see that it's printing this on a clean screen. So this is not in the REPL. This is more of a graphics environment. And so this is the way that the program runs. And there's a lot more to be said about this, but time is short and there's so much to learn in this world. So we'll just keep moving. And so here is kind of the temperature sensor setup that I would encourage the student to use. And here you can see the temperature sensors kind of fashioned into a ring using a little fuzzy wire. They can slip this on their finger and have fun, doing that. And so with that said, what I'm going to do, Eric, is I want to connect the temperature sensor. I'm going to connect this temperature sensor over here, but I want to do it from scratch. So I'm going to go outside of this document, and I want everyone to see how to get started from scratch in Python. So I'm going to do that by going to a new document here. So I'll just go to a new document. And here you can see all the different applications that are available in the Inspire. You can see there's a geometry package, kind of a list and spreadsheet like Excel. There's statistics. There's all sorts of cool stuff in here. But what we're interested in is letter A, add Python. So I'm going to add Python. And I'm going to choose number 1 for new. And I'm just going to put in here, maybe just test, nothing particularly original. And here's just a editor, a Python editor. Notice the .py extension. And I'm going to show you what it's like to author a program from scratch as if you're just on the calculator. So I'm going to press menu. I'm going to go to number 8, TI Hub, and I'm going to choose that import statement. Now, we learned how to use the RGB LED, and that built-in device was our first task. Now we're going to do something a little bit more advanced, and we're going to create a temperature object. And so this is a little deeper dive into object-oriented programming. So I'm going to go to menu, and I'm going to choose Hub, and I want to add an input device. I have my temperature sensor plugged into N1 here. That's why I have to choose input device, because it says N. So this is information going into the unit. And so I'm going to go down to add input device. And I'm going to choose number 4, temperature. And now check this out. This is what in Python, this is called a constructor. This is where I create an object. And so I'm going to call this one just my temperature. And so I'll do, my, and we'll go ahead and fill this in and put in an underscore and temp. And so I can call this anything I want, but I just, this is the name of the temperature object. And now if I press tab, here it gives me a menu choice for the different ports. And remember, I plugged it into N1 right here. And so there you can see N1. And so I'm going to match that right here on the calculator. And now I've just done a construction. So my temperature is the object for the temperature sensor. Now what I want to do is I want to go in a continuous loop measuring temperature and displaying it. So I'm going to go to menu, and I'll go to the hub again. And there's some really nice little help commands here, little helper functions. And so if I press number 5, one of my favorites is this number 4 right here. I'll explain to you what this is. So while is an indefinite loop in Python. And get key is a function that polls the keyboard on the calculator. And the key up here in the upper left is called the escape key. And so I have the Python operator while get key, that's going to return the key that was pressed, is not equal to the escape key. So if I were to press the number 8, 8 is not equal to escape, so that's true. And since that's true, what's inside of the block statements, that will be executed. But as soon as I press escape, escape not equal to escape, that's false. And this will cause the indefinite loop to quit. The bottom line is this is a really easy way to repeatedly do something like measure a temperature sensor. And so let's do that. I want to measure the temperature sensor. And so I'm going to stick this into a variable called T. I could call it whatever I want, but I'm going to call it T. And I'm going to say T equals. And remember, I constructed this object called myTemp. That's a variable now. And when I press this variable key, you'll see the name of that object. There it is right there, myTemp. And if I just press the Enter key, it pastes that in. Now, here's where some interesting object-oriented programming comes in. So if I press the period after that object, it shows that that object has a method called measurement. And if I press Enter, it pastes that method in. And so this is kind of a neat way to introduce students to object-oriented programming. And so I'm going to press Enter here. And now I want to print this. So again, I'm going to go back to Menu, and I'm going to go down to the Hub, again, number 8. And there's another fun command in here, and that is TextAt, number 2. And I'm going to, there's 13 rows on the calculator. I'll just kind of put it someplace in the middle, maybe 4. And then I'm going to tab, and I'm going to type in temperature equals. And then I'm going to come over here, and I'm going to put a comma right here. And I'm going to use the type command to convert my temperature into a string. And so right here, I'm going to do the adding of 2 strings together. And I'm going to go to Menu, and you can see here's built-in types. And under number 5 is type. And I'm going to choose number 4, str. And I'm going to put temperature, that's my temperature value, and I'm going to convert it into a string. And then I'm going to add to that a unit. Let's put a unit in there. So to get a print, or the parentheses for a string, is the control of the multiplication key. So there's my multiplication. Now, I'd really like to have that little cool degrees symbol, and that's under this little symbol key right here. There it is right there. I'm going to choose degrees, and then I'm going to put in a C for centigrade, and I'll go ahead and, I tell you what, that probably should be an uppercase C to be right. So I can do uppercase C's. How about that? And so now I'll close that up. And now here, what I've done is I've joined these 3 strings together. I'm going to go to Tab, and I'll go ahead and put this into the center of the screen here. And then I'll come out of the end of this and press Enter. And now here's my my temperature sensor. And then I'll go ahead and let's slow this down. So I'm going to go to TI Hub number 8. Oops, let me get out of here. Number 8. And I'm going to go to my commands, and I'm going to go to sleep, number 1. And so we've tried to put the frequently used commands under Hub, even though sleep is in the time module. And I'm going to sleep for 1 second. Okay. So let's go ahead and run this. I'm going to press Control R. And sure enough, there's my temperature. And so when I take my temperature sensor here and I warm it up with my fingers, the temperature goes up. Or if I put it on my ice cubes here on my little glass of water, you can see it goes back down. And to complete the project, like I showed you in the beginning, we would basically take what we learned here, the temperature sensor, and what we learned prior to this, the color output, and we would marry those 2 together with a little if-then statement and say something like, if the temperature is less than 18, let's make it red. If it's greater than 18 but less than 20, let's make it blue. Let's display a message. And when you go through all of that, you have the mood ring. And so we found that this is a pretty fun little introductory project. It gives students all of the skills that you need for learning how to do feedback and control. You can see there I should have cleared the screen before I did this, but that's okay. And it's a great segue into some of the other projects that you'll find on the TI STEM Projects website. So Eric, I'm going to hand it back over to you, and maybe you can tell us a little more about some of the STEM projects, or if there's any questions out there, we can answer those.
Yeah, sure thing, Fred. Thanks for that demo. You know, with the time, but it was really nice to be able to see. You had a couple of outputs. You had the RGB LED, and you had the print to the screen, and those were the outputs.
That's right.
And then you control those outputs with the data that came in from that temp sensor, which you showed everybody was the input side of the hub. And I think that's really cool. And I know we've done this project with middle school students and high school students. I think we've had a few upper elementary programs as well. And so it's a great project because of its flexibility. You know, you can do this with just about any group of students. You know, I think probably 4th grade on up. One point you mentioned, and I want to reinforce it, is that typically this project takes about a total of 6 hours. And that's if you do everything. And you do the science activities, you do the coding challenges, you do the whole 9 yards. And there's even some really cool optional kinds of things you can do for the students who, you know, if you need differentiation in your classroom and you have students that are coding experts and they're just moving on quickly, we got you covered because they can do a lot of the optional challenges. Whereas if you have new coders that this is all new to them, despite whatever age they are, adults like me, you know, you can throttle that and you can give them experiences that are going to get them up to speed. So, you know, it's hard to get that across in an hour-long webinar, but I thought you did a great job of showing sort of the two big parts of the mood ring. And yeah, with a little bit of time we have left, I want to encourage people to ask questions in the chat, and then we'll answer those, you know, as they come along. What I want to do now is let you guys know that you can find a lot of these resources at our website. And our website it's TI-STEMprojects.com. So if you type into your browser TI-STEMprojects.com, and we'll put that in the chat for you. It'll take you to the TI STEM Projects website. You'll see this cool little green banner up here. Here's your groovy mood ring icon, and you'll see a host of other icons here as well, because the mood ring is not the only project that we have available. We have a bunch of other ones. But currently, because Python is so new to TI, the digital mood ring is the only project that we have for Python at the moment, and you know, that'll change over time. If you have older TI technology, TI-84s or TI-84 CEs, that is, or TI-Nspire CX, that's the older version of CX. You can still do all of these projects using the TI Basic version. So we're talking about Python tonight because it's the thing that's kind of new, but you can still do any of these projects using TI Basic, and I just wanted to make mention of that. But tonight's about Python, so let me go to the TI-Nspire CX II Python activity. You would just click under Moody Hues, and I'm going to do that now. And then while that's loading, I want to also let you know that we have another resource for both TI Basic and Python called 10 Minutes of Code, and we'll put that in the chat also. And the 10 minutes of code is great because it introduces students to pure coding. Students have no prior knowledge of coding. They've never coded before. You can start them off with 10 minutes of code, but you can also start them off on these projects as well. The TI STEM team, in my opinion, has done a great job of trying to use these projects as a way to introduce kids to coding. Hey, Fred, I heard you there. What's up?
Yeah. Hey, do we have anything for biology?
From an activity point of view? Project.
Yeah, from one of these projects. We had a question coming from chat on life sciences.
Oh, heck yeah. So we've got a couple of projects that have some biology ties. I think the most, or the easiest one to talk about is this heart project, the 4-chambered heart. And so if you're doing body systems with your students, this is a great activity because you literally create a model of a heart, a human heart, using Play-Doh and some LEDs along with your calculator and your hub. And it's a really neat project because it gets into how the heart works, the electrical side, the sort of the liquid plumbing side of the heart. So that's available. Another biology related, more of an environmental science related project is the smart irrigation project, which basically the kids are challenged with coming up with a system that uses water efficiently for crops, for growing crops. And so you could really get into this project by having the kids actually grow. We would recommend like radishes or lettuce or something that has a pretty quick germination or growth time. But that's a neat one because they actually make an irrigation system that's smart, sort of a hands-off irrigation system. And then finally, from a biology point of view, if you're looking at body systems, homeostasis, this one's interesting because the Pet Car Alarm Project basically challenges kids to try to make a model of a car that recognizes the presence of a pet and helps to avoid the pet. Sometimes every summer you hear about horrible stories about pets or children being left in cars in the hot summer, and heat stroke usually ensues. And so this is a project that challenges kids to make a system with basic coding and basic components to avoid that happening. And so that's a really neat project too that's also related to some life science kinds of things. There's all kinds of stuff here. I encourage everybody to check it out. If you're into robotics or introducing robotics, these are great projects down here. And with the little bit of time I have left, I do want to let you know that if this is all new to you, if it's something that you want to do but you're just not sure how to get started, TI has a team called the TI STEM team. Fred's a member, I'm a member. There's a few other people that are also members. And our mission in life is to help you do STEM with your kids, your students. If you need help with anything, I recommend you go to this website, TI-STEMprojects.com, click on the Get Started Now button. And when you do that, there will be just a simple little form here. And all we're really looking for is who you are, how to get a hold of you, where do you teach, what grade level, all that kind of stuff. We're not looking for we're not trying to sell you on anything. We're really just trying to help you get started. And so we'll set up a meeting with you. We'll talk through, how many kids do you have? What kind of equipment do you need? If your school doesn't have the budget available for this, we have a loaner program. We'll loan you the equipment. We'll loan you everything. And so, we'll loan that to you for up to 30 days. And that way you can kind of try this, see if this is something you're interested in. And like I said, you have access to the TI STEM team members in terms of helping you. What's really nice about this
Eric
project. Yes, go ahead, Fred.
We've actually had some success with learning online and at home, right? We've had camps run virtually during COVID, and you've helped them get equipment, and so that's kind of been crazy, but it's worked really well being done that way. So this isn't limited to just back in the classroom, right?
No, that's a great point. And all of us are trying to get through 2020 with COVID, and hopefully we're getting to that point. But if you want to do this and your students are virtual, we can help you. And like Fred mentioned, we've done this project with a number of students already this year virtually. And so the model that we've found that seems to work pretty well is if you're the coordinator of your school and I can send you loaner equipment to your location, then you can distribute it to the students. And what some of the coordinators have done is they've had the parents kind of drive to the central location, pick up a little kit of the equipment, take it back home to the student, and then we all get online and we run through the camp together. And so that's an option for you. We encourage you to try that out. Obviously, if you're in person, this works really well also. So we can do it either way. And thanks, Fred, for bringing that point up. And I think, over the last few years that we've been doing these camps, we've had over 200 teachers and probably between 8 to 10,000 students participate. They've done the project. So this is something that we know how to do, and we're here to help you, and we want to help you. So please take advantage of that, and we can help you and your school get up to speed on some STEM projects. And then real quick, I've got a couple of minutes left. I want to jump back into this digital mood ring, the Python link. And the reason is because if you click on that link that I was on there just a minute ago, I'm going to go back to the main page so everybody sees what I'm doing here. This is the TI-STEMprojects.com page. And when you go to this page, you'll see that green banner. And just scroll down till you see that groovy mood ring. And then you're going to click on the Python version. And when that pops up, it'll take you to a page, and we're working on the look and feel of this page, but for now, all the relevant information's here. There are a number of getting started videos. If you've never used a TI-Nspire calculator, there's a quick video on how to use it. If you've never written a Python program, here's a video on how to do it. There's just so much information. Here's a link to that 10 minutes of code. Here's how an actual mood ring works. So, you know, something from the 60s, you can kind of check out the science behind that. And then all the student files are here. There's PDFs. All of this is free. It's on the website. You don't need to log in or anything like that. You don't need to subscribe. And then all of these videos. So Fred mentioned part 1, and he mentioned part 2 of the project. And so those are here. And we split it into 2 parts: coding challenges and science activities. And so you can watch those videos, and they'll pull up on YouTube, and there are these playlists, and Fred walks you step by step. And so you can literally just assign this to your kids, and the students can watch it on their own, and they could do this project completely on their own if they wanted to. Or if you prefer, you know, the TI STEM team, we can schedule a time to where we can help them online, do it live on a Zoom chat if that works for you. So just, I want to make sure everybody was aware of how that worked. Okay, so with that, I think I'm about out of time. Fred, is there anything else that I missed that you want to mention before we wrap up?
I don't think so. You know, we did have one person asking about activities that don't require hardware. And I would just like to mention that there is science-inspired activities also. So I don't think we have time for you to show that, but TI Science Inspired, perhaps Allison maybe can send a chat link to that.
Yeah, absolutely. The TI Inspire lessons for science are scienceinspired.com, and they're middle school and high school, correlated to all state and national standards. Most of them are simulation based, and the simulations are beautiful. I mean, I mean that they're beautiful. They're very engaging. So so check that out. Thanks for bringing that up too, Fred. That's a good good call out. All right. Well, with that, thanks everybody. Hopefully we'll do some more of these webinars in the future. I'm Eric Archer, Fred Foch, and
Fred Foch.